Okay, so you should be able to see my screen now. So we're just coming to the end of our first year as this current and emerging threats to crops innovation lab. So we're the management entity here at Penn State, and we have a large team of both US groups, particularly the land grants, but also CGIR globally, ICIPE, and then other partners in local countries. So when we were constructing our project, we really focus on this phrase by the administrator, Samantha Power, about 4 interconnected and gargantuan challenges confronting the world. So she wrote this just over a year ago, and really just over a year later, we truly see what sort of difficult time we're in with the intersection between climate change, conflict, COVID, and democratic backsliding. And I'm going to come back to this a number of times during the talk. But certainly we're in an unprecedentedly difficult time, and it's only going to get worse over the next 5, if not 25 years because of climate change, which of course is front and center for Somalia. So because we have this difficult time in which we have to deal with multiple threats, we constructed our application to really reflect this. In a time of challenge, you need an SOS system. So this is for us surveillance, outreach, and solutions. So surveillance is critically important in a climate change world because none of us know what threats are going to happen or what compounding threats we will experience. So what is the intersection between drought and agropastoralism in Somalia, for example? But at the same time, like other innovation labs and like the history of the Bureau for Food Resilience, we really need to have research for the solutions and reaching hundreds of millions of people. So research is critically important, but we must necessarily make it so that if we do respond to threats, we must respond for the entire area. For example, in agropastoralism, it might be across the entirety of the Sahel. The way in which we've done surveillance is as a byproduct of education. So here are 2 farmers in Busia County in Western Kenya, Rosalind and Emiliana, and they, like all farmers in Africa, lack access to extension services. So what we have done for the last 10 years before we became the Innovation Lab is pioneer the development of artificial intelligence, which works inside smartphones, 100% offline, to provide expert level education for farmers. In this case, Rosalind is providing Emiliana an understanding of the viral diseases of cassava. So now the education is happening here. And this is incredibly powerful because this AI system is twice as good as a human. So all of a sudden, we have this ability to act in a very different way than historically we've done. And this surveillance that we have done before we became the Innovation Lab, and now continuing, actually speeding up since we've become the Innovation Lab, is surveillance for the United Nations, particularly FAO. So I was a staff member at FAO for 2 years, and we built a suite of apps for them. And those apps are operational across 60 countries and 30 languages. So we have a very large platform globally. And that platform has had considerable success so far. So particularly in the desert locust crisis, the tools that we built during what was a crisis within a crisis, of course, locust happening during the COVID pandemic. So in this case, we were enabling FAO to have accurate records across Somalia, Ethiopia, Kenya, and Tanzania, Uganda, and so on. And also provide, so that's surveillance, but also providing an output. So we were reaching 16 million people a week in Kenya and Ethiopia, and some also in Somalia. And the impact of that collectively was food saved for 40 million people. Actually, we were very much engaged with Mercy Corps, which we can come on to later on, because I know you work closely with them. And our knowledge partner was FAO. Once the locust left, of course, the drought just got worse and worse. So we co-opted our system, and now we reach about 8 million people in Kenya for drought alerts and education, 5 million in Burkina Faso, and 7 million in radio in Burkina Faso, and 2 million starting in Uganda. And the impact of that is still being assessed because we're still in the crisis. But what we do know from our research on this is that 92% of farmers change their behavior based upon the information we send, and we send the information from USAID's FuseNet program. And so the surveillance, outreach, and solutions effort is critically important for us to operate at scale, but the research component is really fundamental to what every innovation lab is trying to do. So we have lots of research ongoing from Honduras to Burkina Faso, Kenya, and Nepal, but I'm just going to focus in on Kenya because that, of course, is a neighboring country, and it's one which is undergoing the similar challenges to Somalia, particularly in the context of drought, compounding problems of pests. And so what we're currently doing across Kenya is a multifactorial experiment on maize performance across diverse agroecological zones, from Homa Bay on Lake Victoria to Kilifi on the coast, across 2,000 fields. And we have 5 different treatments, and we want to see what is the effect of these. So the first is climate smart advice. Doesn't matter if you tell a farmer what's happening and what the crop water balance will be, when to irrigate, how to irrigate, or to use approaches which will hold more water in the soil. The other is the control of fall armyworm, which is now becoming a chronic pest across Africa, and we do this through parasitoid wasps with ICIPE. Then another one is striga, which is a terribly impactful weed, which we're controlling through a bioherbicide. The fourth is maize leaf necrosis, working with CIMMYT on the control of this through clean seeds. And the fifth is generally approaching the problem of poor soils in East Africa and using leguminous plants through intercropping. So these 5 interventions allow us to frame a number of hypotheses. The first is that the effects are multiplicative. So the interactions that we're going to see across 2,000 fields allow us to see if is fall armyworm plus striga control better than fall armyworm plus maize leaf necrosis control, or is there an interaction such that you get added benefit from fall armyworm plus striga control or striga plus intercropping. So these are the approaches we can take with a generalized linear modeling framework, something like also random forest approach. So look at how the effects multiply together rather than simply add up. I think that's an incredibly important question. The other, and we're already seeing this, the agroecological zone plays a decisive role. So being able to span 2,000 fields from Lake Victoria to the coast, we're going to be across multiple soil types, multiple rain systems, but also interaction with temperature. So the agroecological zones that underlie all of this are incredibly important. And then the third hypothesis is that farmers will pay for some, but not all of these inputs. And that's a critical thing because we need to double down. So our second experiment will be asking questions, how will farmers, and we're working on the economic aspects here. But just to give you an insight into the results so far, so we're very much in the middle of our experimental work, but these are just some of the results that we're seeing and really quite striking. This actually, this was planted on the 26th of March and this was planted on the 25th of March. These 2 fields are contiguous. You can actually see this one in the background over here. And the effect is dramatic because of the introduction of the approaches that we put are leading to greater yields. Now, we only have a little bit of data so far, but what we can see for the cobs, which are being harvested in the experimental fields, it's about 2.5 times more than we find in the control. So about 4.1, 4.2 compared to 1.8. So really, really strong effects. And this is just going to increase. So we're seeing in what is the worst drought in Kenya, the worst long rains in Kenya in 70 years, and the worst 5-season drought in 40 years, we're seeing really productive gains because of the approaches. So we'll continue to learn more about this as we gather the data and do the statistical models to tease these things apart. But that's the research component of what we're doing. When USAID were asking people to reply to this call and respond, they very much had in mind biotic stressors like fall armyworm that I've just mentioned, but also locusts, which of course was a huge problem that was on everybody's mind, things like maize leaf necrosis and striga and so on and so forth. Since then, we've had 2021, and 2021 showed us that the biggest threat is drought. And that, of course, is so important for Somalia. Somalia is facing a risk of famine, IPC phase 5. We've worked with FuseNet for 2 years now, cascading out their maps to millions and millions of people. So we're very much aware of how this has been slowly building up over time and the critical situation that Somalia is in. The last significant drought, of course, killed about 300,000 people, predominantly children. And so we're facing a dire circumstance at the moment. And so fundamentally, what we have to do is try to go from the left-hand side to the right-hand side. And we have to do that in the challenge of an incredibly bad drought and the worst drought in 40 years. And so the danger is that we cannot become resilient. We're just going to be throwing more food out of the back of airplanes or trucks. And in preparation for talking specifically to Somalia, I engaged with David Beasley's office, his executive assistant, Gavin Garmstead, with whom we worked. I engaged with OSHA, Mercy Corps, FAO, and other partners in the region, just to really get a good handle on the issue. But very much so, we're looking at a situation of emergency response. But we would like to argue to you today that we can actually do something beyond emergency response. We necessarily must save lives, but we can also put in place a system that enables resilience. And at the moment, resilience is not happening. It's just not working. We can't. There's too many barriers to farmers becoming resilient. The last 5 years have shown how we have increasing food insecurity. What Administrator Power talks about is we're losing decades of developmental gains. And so research has an important role to play. But the problem of research acting as a pillar is that there's still gaps. And so it's still difficult to overcome this. So there are gaps in our system, and that stops us becoming resilient. The way in which we have to think about this is not just having research, but also having extension. So this is the T model that there other AOR, the alternative AOR, Zach Stewart, talks about in trying to have research as a pillar, but then a T-shaped function so that we're able to have extension and scale out the research findings. And that's critically important. And if we do that, then we do have the potential to go from food insecure to resilient. And I think that's critically important because this acts as a way in which we can take advantage of the current crisis to do something different, so we're not going to be in the same position in 2 years. And so let me give you an idea of what that looks like. So this is our platform. So here's Somalia, and every day this map is updated. This is the map coming from FuseNet. We've done a lot of stuff in the cloud in order to develop that and get it out. And not only can we get it onto this platform here, but actually it can go out to anybody's email or anybody's SMS. And we send about 500,000 SMS messages a week in Kenya. And as I mentioned, it goes out to about 8 million people on TV. But let me just look at Kenya for a moment, because that's where we have the greatest footprint, because we already have concurrence to work in Kenya. And one of the things that we can do, importantly, for drought, is that we can look at different counties and the likelihood of the maize crop being successful. It's not sufficient to think, does the maize germinate? It's important to see, does it produce in the tillering stage? Does it produce pollen? Does it have cobs? Will it lay down cobs? And in many locations, we can see, based upon the crop water balance, that if you planted after a certain date, say the 22nd of March, you're going to fail. And that's exactly like that field I showed you. That field is failing because of a lack of water. But as you saw, the experimental field didn't fail. So there are things that we can do. We can both know the threat and we can respond to the threat. And then the other parts of the platform are looking at the use of it. So if we just look at Kenya, for example, we can see people. Frederick, one of the farmers, is using it, and he would have had it offline, but we can actually see the record afterwards, and we can check the AI. We can send a message to that person directly and engage with them. The other thing that we can do is we can check this thing called the observatory. So once the records are checked, we can pull them in. But let me actually just take a little detour, since you're so interested in animals and pastoralism. After the locust crisis, we stayed in northern Kenya, in Turkana, Marsabit, Isiolo, and Samburu, and we can zoom in, and we're providing these services to the pastoralist community. And we're working with the Kenyan government through their disease reporting and also helping the pastoralists increase foraging. And we've already successfully helped the vets respond and treat a rabies outbreak. So, and as well as a goat pox outbreak. Very successful. And we also send content and precipitation maps and vegetation maps to the pastoralists. So we're seeing a wide scale change in behavior among the pastoralist communities in northern Kenya in a way that benefits them. And this, of course, is critically important to the situation in Somalia. But let's go back to the observatory. So these are some of the areas where we're currently working. And the Siaya County in Kenya, and we can look at samples from just 4 hours ago, for example. So this is 4 hours ago. I can show it to you, and we can see who the farmer who had the experimental plot is. And now, right in front of your eyes, we're pulling in multiple satellite streams. So this is really the most advanced cloud system in the world for agricultural development, public or private. And so here we can look at the effective rainfall since the person planted and how much water was needed. We can also, this is two satellites from NASA, MODIS and Landsat, and they're measuring how much biomass is in the field from space in kilograms per hectare. This is a critically important one, which is soil moisture, and this tells us how the moisture is decreasing. This is from expected rainfall. This is from a private partner providing irrigation advice. And this is the most critical part. So I can show you a picture from a county in Kenya 4 hours ago, and you can look at that in the context of 8 or 9 different satellite streams. And that allows you to think about making a decision, sending a message directly to the farmer, for example, making a note on this. And so this really improves our capacity to respond effectively. So that's our algorithmic advice engine, which we call AgTree. And so then we have the potential to really think about something different. We have these young people that we engage, they're called the Dream Team, and we have over 160 of them now in 9 countries. They are real-time connected to 8 or 9 satellites, but also to the global community, such as the US land grants. So there's a group in Kenya who are working directly with Michigan State University on nematodes, but also with ICIPE and IITA, real-time experimentation for research for development. FAO, of course, since we provide all the tools for them, CJR, and then NARUS. And this allows the farmer to effectively respond to threats and insecurities rapidly. And a question might be, well, Somalia is a particularly challenging country, but these are all the records of the Dream Team we had during the locust crisis in Somalia. Not our specific one, but those employed by the government. With young people running across a landscape with smartphones. And so our model is supercomputer charged young people helping pastoralists and farmers. And so far it's working well. But remember, Administrator Power was talking about 4 interconnected threats. In the background, we see drought in Somalia, and that is a problem that we're just not going to get away from. It's going to become worse and worse. But what are the other threats? She talked about COVID, which we still have the negative effects on the continent. Conflict, which is both an internal problem in Somalia, but is now a huge problem because of the Russian invasion of Ukraine and democratic backsliding. And it's the Russian invasion of Ukraine which has us all worried because it's turning off the fertilizer supply system. But as Administrator Power said, this is a choice by Russia in order to hold the global South hostage. So how can we respond to drought and low fertilizers? So here's another one of our fields. There's a lot of things here, parasitoids, but predominantly the reason this field is so green in the worst drought and the worst long rains in Kenya in 70 years is because of the application of biochar to the soil. And that is a drought proofing mechanism. So on the left, we have the IPM package. On the right, we have control. So biochar, and particularly biochar fertilizer, biochar is biomass, which has essentially been baked. And so it's a form of carbon which doesn't break down. And you keep the structure of the biomass. This is essentially a sponge that holds large amounts of water inside the soil, close to the root hair. And when you mix it with fertilizer, local fertilizer, local compost, then you're able to have insurance and proofing against the Russian invasion of Ukraine, which has already tripled fertilizer prices. So this is a tool that helps us in drought tolerance and Russian proofing. And so this is an example of us doing this in Kilifi, a dryland area in eastern Kenya. Very effective, and also co-opting research from Burkina Faso on the use of these, what are called Zai pits. Very effective, holds more moisture in the soil. And so this allows us to go forward through these double crises, impacting farmer livelihoods as well as the livelihoods of pastoralism in a system which is well proven. So this biochar fertilizer and smart cloud powered dream team, it captures CO2, which of course is really important, produced locally, creates new jobs, and it's an insurance against drought. We can have a 42% increase in crop growth despite it. And so again, just to really strike home this point here, this is the business as usual. This is the application of biochar. So it's truly impressive, and then allows us to go into the long rains and the short rains in 2022 and the long rains in 2023 with an effective tool in our arsenal. And so back to the administrator, she talked about this rather difficult situation we're in, but I also was quite heartened by her first address to staff at USAID, that we need to take the risk that this time in this moment in history demand. And I think that's really what I'm trying to get across here.